There's been some recent research to suggest that planets in the habitable zone around red dwarf stars might be safe from their large flares after all. Now, why are we bothered about these planets and the flares given off by these particular type of stars when most stars are going to have some flares anyway? Well, red dwarf stars are very small. They're one of the smallest stars and they're quite cool. So in comparison to the sun, they're about half the surface temperature, which is why they appear redder, why they're called red dwarfs. And some are around about a fifth the size of the sun. So they range in sizes, but they're a lot smaller than the sun. So because they're small and they're quite cool, they don't give out a lot of energy. They're not very bright. So for a planet to have liquid water on its surface, that habitable zone has to be very close to the star. So they're very, very close to the star. This is a lot closer than our habitable zone. So if we wanted to be in the habitable zone around a red dwarf star, we would be well within Mercury's orbit for a red dwarf. So one of the best examples really is TRAPPIST-1. So this has 7 planets that are in and around the habitable zone around a red dwarf. Now, as a comparison for size, that is all inside Mercury's orbit. And it's not just inside Mercury's orbit, it's well within, very, very close to the star. But that's because TRAPPIST-1, the star, is very small and it's not very hot. So those planets that have liquid water on have to be very close. Now, that obviously is quite obvious. That's a very small system, very compact, but we can put it in context of Jupiter. So Jupiter, which is at the center here, and then the Galilean moons orbiting around the outside, size comparison wise to orbits and things like that, it's almost the same as TRAPPIST-1. So the orbital periods of the Galilean moons are on the order of days. So tens of days, stuff like that. And the orbital period of the planets in the TRAPPIST-1 system is about the same. And Jupiter is not that much smaller than the star as well. So it's almost a good comparison to show just how small this star and planetary system is. Now, the big problem with red dwarf stars is they've been known for a long time to have like these flares or super flares. We say super flares because in comparison to the size of the star, they're quite significant. And this is a light curve of a red dwarf star. And that is basically just like the flux or the luminosity, the brightness of that star over time. And you can see you've got some very, very sudden vertical spikes in how bright that star is. And they are from flares or super flares. And you can see that brightness of that star increases massively. Now, they are quite enormous flares, and they are quite a problem, to be honest, for planets orbiting. Because it was originally thought that these planets, as they're orbiting the red dwarf, they're very close to the star. Those flares are going to hit the planet, they're going to strip its atmosphere, and they're going to sterilize them so that you can't have life, basically. So it's not necessarily thought that these planets, despite being in the habitable zone and having the capability to have liquid water, would actually host life because these flares could potentially be directed straight at them. So that was what was originally thought. However, some observations, some direct observations of a few red dwarf stars have actually shown that these flares don't occur at the equator. So planets typically orbit around the equator of a star, but they occur at the polar regions instead. So these big flares are coming out perpendicular to the orbit of the planet. So they're not going to get a direct hit anyway. So this actually is quite exciting and quite useful for looking for life now. Why? Well, red dwarf stars are one of the most common stars in the universe. So there's lots of them around. We've also found lots of planets in the habitable zone orbiting red dwarfs. So you've probably heard in the news we found another planet in the habitable zone. It's an Earth-like planet, but it's a red dwarf star. So my initial thoughts would be, well, we know these have flares. That's not great. Not necessarily what we want to be looking for life. But this new research suggests that they might be safe from those flares after all. So there's going to be a large population of planets in the habitable zone that may be now safe due to these observations. So thank you for watching, and if you enjoy, then check out some of the other videos.